Hello and welcome back. This is Nikola Popovic again with the solution to the calculus problem that I posed a couple of days ago. So remember what the problem was. You are given a cubic, a third-degree polynomial, which is the red curve here. It has three real roots, and you look at the tangent to the curve at the average, the midpoint of the two roots, and you find that the tangent goes to the third root. So today I want to show how you can solve this problem quite easily with calculus. So the first assumption that you make, and that is typical in mathematics, you want to simplify your life as much as possible. So you assume that the midpoint of the two roots is at x equals 0, right? So you assume that it is on the y-axis. So then you can write your function, your cubic, as follows. So f of x, which is my cubic, is a product of x minus some alpha times x plus some alpha times x minus beta, right? So the idea is that you have two roots, one at alpha, one at minus alpha. The midpoint between these two is at x equals 0, and you have a third root at some value beta. So, x minus alpha times x plus alpha, if you simplify this is x squared minus alpha squared. And you multiply that with x minus beta, you get x cubed minus beta x squared minus alpha squared x plus alpha squared beta. All right. So that is this cubic. That's the expression for the cubic that I have under my assumption that the midpoint was at x equals 0, right? So what do I need? I need the tangent to this cubic at the midpoint. And so how do you find the tangent? Well, you need the slope. So you need the derivative f prime of x of this cubic with respect to x. So you will learn that in the course, but I am sure you know that from school already, that this is 3x squared minus 2 beta x minus alpha squared. All right. And so at x equals 0, f prime of 0 is just equal to minus alpha squared. All right. So that is equal to the slope of the tangent at this point x equals 0. So minus alpha squared, which is f prime of 0, is the slope of the tangent. So the slope of the tangent is y minus f of 0 divided by x minus 0. All right. So what is f of 0? F of 0 is just alpha squared times beta. So this is f of 0. All right. So the equation of this tangent is y minus alpha squared beta over x is equal to minus alpha squared. All right. And so, how do I prove now that this line goes to the third root? Well, I have to show that if y is equal to 0, so if I'm intersecting the x-axis, x has to be equal to the value of the third root. So if y is equal to 0, I get that minus alpha squared beta over x is equal to minus alpha squared, or if I cancel minus alpha squared, right, I get that x is equal to beta. And that, of course, is by assumption the third root, right? So this cubic intersects the x-axis at x equals beta. And so I've shown that the tangent to the cubic at the midpoint between the two roots, which I assume to be at alpha and minus alpha, goes through the third root, which is at x equals beta. And that completes the proof. I hope you had some fun with this problem, and as I said, we'll be learning much more about functions and their derivatives in semester 2 in the course. Take care, have a good semester 1, and I will see you in January.